This is the most challenging one.
Yeah. Good evening, folks. We're gonna started here on our Woodson. First of all, thank you all so much for coming tonight. This is the LA Sections Awards Center where we recognize the outstanding individuals and organizations in our AIAA section. So please sit back, enjoy, and we'll get started. So first up is our keynote address. And for this keynote address, I'd like to invite Dr. Hager. Dr. Hager comes to us from Aerospace Corporation, a now retired technical fellow with numerous committees. So very short career. We're going to learn more about him and his work on planetary defense. Dr. Hager.
Thank you. Okay, well, it's nice to be here, and so when I talked to Ken about this, I said, well, what do you want to talk about? He said, well, talk about your career a little bit, and I said, how about planetary defense? He says, sure, and so anyway, we'll see. So yeah, I was an aerospace employee for over 50 years, and I just retired. So I'll give you an idea of where I sit. I know. Wait. Okay. So I'll give you a little bit about my background, just so you'll get a feel for it. I went to North Carolina State University to get a bachelor's and master's degree. I met my wife there, actually. And she was working in the animal sciences, had little rats all over the place. So anyway, and then I went to a place called the Naval Ordnance Station, spent just a little bit of time there, but I was designing small rockets. It was a really nice thing to do. They actually had a proton plant where they had this building that was actually made nitroglycerin, which, if you want to know how you build a building that has nitroglycerin in it, it's basically a fort, very thick walls around it. And a wooden roof. So if it ever blew up, it would go up, not out. And so that was something I stayed away from. But anyway, and I got a PhD from Purdue and was employed by the Aerospace Corporation, which you said before. So that was a lot of fun. I really have enjoyed my work at aerospace, and it's allowed me to do some very interesting things. I thought for one of the things I did too, just put in here as a career background, was I've been involved in my city, not politics a little bit, I guess, but I was in the planning commission for 8 years there and ran for city council. And then based on what I learned there, I set up something called the Palos Verdes Peninsula Land Conservancy. I was the chair for its first 18 years. And it's preserved about 1,700 acres in Palos Verdes. In property that when they said it's too expensive, $1 million an acre, you'll never buy any of that stuff. So anyway, that presentation is pointing strong. If you ever go to Palos Verdes, you can walk the trails there. It's a great place, except that we're having a little landslide problem in a couple of areas. But that's okay. And I retired from aerospace as a technical fellow in 2025. So. Okay, now a little bit on the other side, when I was working there, oops. There we go. So I've worked in the reentry area a lot, looking at things like the space shuttle when it came down, the Cosmos 954, which is something that wanted to spread the radioactive material in Canada. I was working on where that stuff came down. Things like Skylab. I worked on a model that let me predict where the footprint for that stuff was. Happily, when it came down, there was a piece of big debris right where I said it would be. There was a long footprint, but anyway. And then worked on the elated meteor storm and satellite threat conferences. That was some that I chaired. This was when the elated meteor storm was going to come through. They thought it was going to be quite a lot of small meteorites and debris coming in and affecting satellites. So I held two conferences on that, and got the chance to go to NBC. They talked to me anyway about that. And then we had forums on radio frequency interference issues that were going on at the time. Was another one. And then I was asked to testify to the Columbia Accident Investigation Board after that particular accident. And they wanted to know what they could learn about the accident from the debris they found on the ground. So that was quite an experience as well. And also, one of the things that I was working on space debris and was talking to an Air Force general, Pete Ward, if you know him. He ultimately left and went to AIAA and such. But he was talking about space debris. What the hell we're talking about is asteroids. That's big debris. And so I thought about that. And a couple of years later, I started a series of conferences on that topic. And so far, we've had 10 conferences. The last one was in South Africa. The next one's going to be in Montreal every 2 years. We've been all over the world. We've been in Japan and other places, and so it's been quite good. And I drafted a position paper today from AIAA on what should be done to protect Earth from asteroids and comets. So that would you can look at that as well. Okay. And then more on the technical side, I chaired something called the reentry subpanel of the Interagency Nuclear Safety Review Panel for some number of years. That was a panel that advised the White House whether or not they should actually launch something. Would potentially, and they did, would it potentially hurt people on Earth if it had to come in inadvertently. So that was a lot of fun. You see the missions that we worked on. I worked on an ISO International Organization for Standardization on standards for estimating risk in space hardware. We're interested in those things. Patented a little device that was designed to ride and reentry a vehicle coming into the atmosphere. This vehicle is going to break apart. This little thing was on the inside. The astronauts activated it at the space station, and it had two successful deaths. Excuse me. Water. Yeah, maybe so. Yeah, I had a bad cold. Okay, and also as a member of Action Team 14 of the Scientific and Technical Subcommittee of the United Nations Committee on the Peaceful Use of Outer Space. And you'll hear later that we developed protocols for how the international community will work together should we actually find a threat. That's okay, so now we're going to talk about that. So, and I'm going to give you an example from one of our things we've discussed at conferences. For about the last 5 conferences, we've had these threat scenarios that we put on the table. And we work with JPL and others, we make it reasonable. And the question is, what are you going to do about an asteroid that's really a threat? Who needs to make decisions? How fast is that going to work? So I'll talk a little bit more about that. So this is really kind of a cut down version, but it's a quick picture of what's out there. And what you want to notice here is you see at the bottom here around 2000, 1990, something like that. This little curve kicked off when Congress told NASA to go off and look for anything larger than 1 kilometer. And in doing that, they find all of these things. And you can see it's continuing to go up. So what that tells us is there's a lot of stuff that's been out there forever that we never looked for. So, and you can see the numbers here. We have anything greater than 1 kilometer is about almost 900 of those. And so it's been a very interesting time to look at this. But again, we have comets also, but there's a small threat there. And so this, you've probably seen this, this is Barrington Crater in Arizona. And these are some exhibits of what has happened in recent history. First one is in I'm having trouble. First one is in 1908. That was Tunguska in Siberia. Many of you may have heard of that one. It leveled about 600 square miles of forest. And there was nobody there. So that was fortunate. But then also this one in Brazil is still kind of a questionable one. So we're not absolutely sure about that in a remote area. And then on this February one, I was at the United Nations. This is an interesting story. I was working on this panel to develop these protocols for how we're going to deal with the threat. And we had representatives of several nations there, and the Russian guy whipped out his phone and said, "Uh-oh." And he said, "There's one just hit his Chelyabinsk." And so that was quite a surprise. Nope, we didn't see that one coming. That's bad. And by the way, this is what the Tunguska impact area looked like compared to the rough sides of New York City and Washington, D.C. So you can see that even a small asteroid can be a real problem. And that was about this one. Tunguska was about a 30-meter in diameter asteroid, a relatively small one. So as the United Nations have been looking at this, and so we debated this and wrote a process now for and have it in place so that if this International Asteroid Warning Network, which brings together observations from telescopes worldwide, says there's something that meets the criteria of a threat. It has to be greater than 50 meters and detected with a probability of impact of greater than 1%. Then that means that they will notify this next group called the Space Mission Planning Advisory Group. And that one will coordinate space agencies' recommendations for actions that they take that actually take it out. And those that could include a fast flyby mission to try to figure out what it is, or to characterize the object itself. And if you have to, you might have to deflect it. So that's where that would go. And I may have mentioned one of the real issues with planetary defense is this decision-making process. Because once you find an object like this, the clock is ticking. And if it takes a long time to make a decision, you may pay for that. And so, we had the last conference we had at the United Nations. Well, I'll show you a picture of that. We had a conference at the United Nations there, and they us through their hall, and we had 150, 200 people there, and that we were trying to figure out what do we do. We actually have lawyers in the room. Can you imagine? And so it was very interesting to see, and the entity that would need to approve any use of, I'd say, a nuclear explosive in space would be the UN Security Council. And so all of this stuff is going to take time, and you'd have to allow for that, which you're doing these. And so we have actually had a scenario like this for both of our conferences recently, and tried to discover that. And having the lawyers there and people in the United Nations involved was a big deal. Okay, I'm going to give you a quick example. So this is from one of our threat exercises of the 2023 exercise. Okay, so then we basically said there's a 220 to 660 meter object discovered that has a 1% of probability of impacting Earth in 13 years. And this gives you an idea of what the catastrophe might be, what would the scale of something that size hit, what would they do? And so that said, it would be not good. Okay, so we're 13 years before impact. You don't know if it's going to hit for sure at this point. And this International Asteroid Warning Network recommends that we do a mission to get better information and characterize. And we don't know whether it should be a flyby mission or something where you'd actually orbit the asteroid, but be good go on. And so that would be quite useful. I forget where this one was, but we did one where we were saying that if it actually were to impact, and one of the places it could impact would be Tokyo. And we did that in Japan. We had the conference in Japan, but we have somebody from that area on the panel that tries to make a decision as to whether to use the nuclear explosive to take out an asteroid. And as you can imagine the Japanese person on the panel had a heck of a time deciding that we really needed to do that, because otherwise they'll take out this ocean. So it was bad. But we try to do that just to see what we really need to be prepared for. And one thing I thought was interesting, in addition to what it would be, just trying to explain that, was what the loss of Japan do to the world economy. Because this is quite a player in a lot of areas, and there are other issues that we need to think about when we're having these type of things going on. So anyway, we looked at that case and we did something different about how we handle it, but these agreements and processes in place that if you have to do something are very important, and that's one reason why we sent that committee up to look at it. Okay, now this is what that particular case would look like, and each of those little red dots is actually a continuous line, but there's what all that means is that object is somewhere along that line, and you with your observations and so forth, you don't have perfect information on this particular one, so it gets closer. By the way, we did one for that came down Sunbelt was going to hit in the Pacific off of Los Angeles. This was done for the state of California, so I'll tell you more about that one. But anyway, this one came down, and you can see how it's coming in. This is how it's evolving over time, given what we know about it, and you can see it's going to have this would be you would find out where it might hit, and this thing when it crosses Earth, that's it on one side, and that's it on the other. And so the question is, how do you deal with something like this? And you won't know better information until it gets close. For example, in the case where we were doing the one in off of Los Angeles, it took us about, I don't know, a week or two to get radar data on that thing before we knew exactly where it was going to hit. It didn't pass it, but the problem was, what are you going to do with how would you, if you were going to try to evacuate people from the LA area? How would you do that? And what would the effects be? I mean, you probably kill a lot of people trying to do that. So it's really a lot of issues come up when you have these scenarios. And so on this one, they had new observations. It's going to impact in 12 years. Probability is 100%. You see the size? It's going to be anywhere from 6 megatons to 10 gigatons of the equivalent. Millions of people are going to be hurt, and where is this one going to come down? West Africa. And so, and we actually had a conference in Cape Town area to go over this and see how they would respond to it. And so we had opportunities to deflect it, and you can see what the issues are there again. We're going to deliver the minimum mass to assure deflection away from Earth, assuming no mission failures, of course. And look at the connection of the alternatives. One of them is a kinetic impactor, which is where you just hit it with a big rock or something. And the other one is you can use a nuclear explosive. And you can see that you really don't have a choice. And so that's another one. We actually much earlier than this, we had one that was going to land just off the shore of France. And the question was, would they agreed to let us use a nuclear explosive to take it up? The British representative said absolutely not. And so we're not allowed that path. So those are the kind of things that would be interesting. But anyway, you look at the differences in how much you better carry, and you can use if you use a nuclear explosive, it's actually something you can probably do. Okay, so that's where that was. It came down in South Africa, that area. We designed it particularly for that. And just to give you an idea, we have NASA Ames does a great job. They have models where they can predict what kind of problems you're going to have all along, what's the average hazard for people and so forth and so on. So they do a really nice job of estimating where the hazard will be, tsunamis, such if it hits in the ocean. And then people say, well, can we actually move an asteroid? As you probably know, you probably know about the DART mission. That was a very good one where they actually hit this move and changed its orbit. And actually found out recently they changed the orbit of the system too. So that's very interesting. So it can't be done, but kinetic impacting items can handle only a certain size of objects. Okay, and then we've done exercises to DOD, FEMA, and the White House, and we've had stuff looked at. Well, the state of California talked about that one. And also other space agencies have done the same for their country, the Germans have and others have. And we have a plan now since we've been doing this. And the plan is So this is, if you want to see what the US is going to be doing about it, this is the National Preparedness Strategy and Action Plan for Near Earth Object Hazard and Planetary Defense. And this was put out in 2023. And you can see basically what the goals are of this. So in any event, people are taking this threat seriously. I don't think it's a good time to know that. And some of you might be involved in trying to make one out one of these days. And then some coming events. We have a conference coming up in Montreal in 2027. And I reckon, again, these things are really good. You get all the experts in the world up in various things, legal people, technical people and stuff, others. They come in and talk about what are we going to do about that. And in 2029, we have a very close flyby of Apophis, which is a very large, 300-meter asteroid. It's inside, it will come so close, it's inside the geobelt, and you'll be able to see it with the naked eye if it goes by in the right place. Let's see, we're having a conference in 2029, we'll have another conference, and it's likely going to be in Nice. Do you think that's a good place to be? It's also a good place otherwise. That's right. So that'll be an interesting thing, but that'll be at a time we think it's going to be a really good time for conferences, so that should be fine. And then I'm also on a United Nations group, a panel that's working on something called the 2029 International Year of Asteroids and Planetary Defense. The purpose is to use that event as a way of educating people about these kinds of threats and what asteroids are and all those kinds of things. So you're going to hear more about that. It'll be coming out in a number of different ways, I think. And if you want any more information on these things, you can get it here. There's a couple of places on that. If you go to the JPL site, they've got the summary reports that I wrote most of them that are on each of those conferences, what we learned from them, and so forth. And as I said, the first conference that we had in 2004 ended up in being an AIAA recommendation of the policy for doing that stuff. And then then if you want to see more about the what we know about the asteroids and things and where they are, how big they are, and if there's anything coming close, that JPL site is excellent. So, and this is a picture from the United Nations facility when we were in there, and you have to look closely, but I've been there, a lot of others there. But that was a lot of fun. We had a good time there, and we had a great time. We had good people participating in these exercises, so it's great. I think that's it. Any time for questions? Yeah. Okay. Any questions? Yes.
Why would you do a flyby rather than reconnaissance? Because that just adds additional time to your decision-making time.
Yeah, it just depends on what's the best way to do that. You want to get something there fast and don't want to have to slow it down. You might be able to go by it really fast and pick up a lot of information about it. Actually, when I talked about in Japan, it turned out that particular asteroid had a move that was bad enough, big enough to cause a lot of trouble. And so in that case, we did that. We actually orbited a spacecraft around that, the body, the main body, and that, unbeknownst to the Japanese, was carrying a small nuclear explosive. So ultimately, we had to use that to save Japan. But I think you're right. The orbit, if you can stay in the orbit, you get everything you need to know about it.
Right.
Anything else? Yes.
In your analysis, how big a nuclear device are you talking about?
Well, we actually brought in let's see, the National Labs, Mark Livermore, people there who can really do these kind of things. And they actually came into some estimates on what you would take. We actually did a lot of testing and computer simulations for that. And so we let them decide what they need. Yeah.
Do you have a probability of actually hitting the Earth with the one that's coming by in 2029?
2029? No, I don't think there's any chance of actually doing either. All right, so it'll come very close. But as a matter of fact, when it was first discovered, that all actually the asteroid came Apophis. you might hear, if you, that's the Egyptian god for what, death and destruction. Yeah, very poor name for that. So anyway, but, there's not, right now, it's just gonna come very close.
How close?
Within the geoclinic, which is very close.
Geogram, that's pretty impressive.
I know. If you go on the satellite, that might not be what it's talking about, not that it could be much. But, anyway. Anything else? Yeah.
How much nuclear ground testing would be required to develop the capability to, like, use that nuclear device to meet the threat? I asked you earlier.
Well, I think that the specialists have really good models for doing this kind of stuff, so I think they can, they've got the capabilities to do it. Yes.
Have you seen any Hollywood movies that sort of really nail it on
Well, as a matter of fact, there's a movie called Asteroid Hunters. It's done, it's an IMAX movie. Some of us here, not who is in that movie, I've been there a little bit. And, but it's a really nice show. It's a very realistic one. It's nicely done as IMAX you would expect to do that. And it was funny, when we were doing an exercise in Italy, I think it was, there was a person there from IMAX who's ultimately came over to us at Aerospace and said, we ought to do a movie on that. And so he invited a couple of us to consult with him and so forth. And we had JPL involved. And so it was quite well done, I believe. Just like people know how. Any other questions? Yes.
There's the movie by, by the old space agency.
Ah, good.
Okay.
I don't know about that, but that's good. Have you seen it?
The last one.
Oh, what? Yep. I must have missed that one. All right. Well, good. So, yes. Go ahead.
You talked about nuclear explosives, right?
Yeah.
Is the idea of using a high powered laser a possibility or not at all?
I don't think you can get not laser on a big object to do much.
That's what I presented to Bill in Prescott. Over, Bill,
Yeah.
he was still moving.
Yeah,
We talked about.
yeah. It's gonna take a lot of energy, or you can tell it's gonna take two people explosives to move something like that. You'd have to hit it a long time for laser, and that would be the problem, I think. Anything else? Yeah.
How soon in advance do you need to know about the asteroid or do something about it?
Well, you have to go through the process here, that we talked about that, the sooner the better, and the clock starts ticking, and you find one that you think is close. So you do that, you can see that you have to get a lot of information on where it's going, where it is, where it's going to be, or you can actually decide what you want to do about it. And so, it'll take a long time. The time is really of the essence here, I think. If you're worried about that, you've got a lot of time, yes.
Most of this is assuming that it's coming into maybe the solar, into the planetary plane.
Yeah.
What about things come in, well, also from inside of the Earth's orbit?
Mhm.
And all the things that come in out of the plane.
Yeah, actually, that only thing that belly bits, we didn't see it because it came in from the sun. There was another one we were looking at the same time, and that one we knew was coming down, but we didn't see that, the one came in. So it makes a big difference where these things are, and more information you can get, the better.
We have plans for searching out of the plane.
Oh, yeah, we're seeing where they're getting these little out of plane and out of solar system bodies with and through too. So those are interesting. So again, we're learning a lot now. And again, if you look at, remember that chart where we saw in 1988 or something like that, we only knew about maybe 10 asteroids. Learning a lot more. We got a lot better instruments.
What are the primary data sources? Are there actually instruments that are scanning the skies periodically, or is it coincidental with astronomers who are doing science?
I think a lot of that, these big telescopes are putting in, they look for asteroids, and they get a lot of, actually going back and looking from the old negatives from photographs of the sky, taken by those, looking for asteroids there. So it's a lot of work going on, but we've got a lot of good ability now with that. Yes.
How much do these Leo mega constellations interfere with observations required for planetary time?
I think this doesn't hurt. It doesn't help. I don't know how they, how they tune those things off, from the measurements, but that is a problem as you read about that. These satellites are bright. Okay. Anything else? Okay, thank you very much.
I'll send you this morning to thank you for not only your address, but your.
Well, thank you.
Thank you so much. Thank you. We'll take a slight detour from our program here. I'm gonna turn things over to Dr. Pujol, who's gonna present the James research.
Thank you very much, Luis. It's my pleasure to introduce Jim Wertz, as we know him. We named the scholarship after Jim, I don't know how many years ago now, at least.
400 years, right?
Yeah. Jim has done a lot for this section. He's been chair multiple times. Some of you may remember the Reinventing Space Conference or the Responsive Space Conference from years ago, which is way ahead of its time, frankly. You're a pioneer in thinking, you're an entrepreneur, a professor, and an author of a very well-known book that you may have heard of as well. So it's my pleasure to introduce Jim, who will then present the award and after them.
I'm certainly happy to present the scholarship award that is done every year. This is the James Wertz Scholarship, and we're delighted to have our scholarship winner. I don't have a lot of hope of being able to pronounce her name. Why don't you come on up here and stay? If you'd be kind enough to pronounce your name for us, I would appreciate that very much. And anything, the key issue here is she's done a lot of work on debris removal, getting rid of the space debris and things of that sort. A clearly key and critical issue at the present time. The amount of debris is increasing dramatically. The number of spacecraft in space, now about 10,000 or so, could go up by as much as 2 orders of magnitude. And that's going to create an enormous amount of debris, to say the least. Getting rid of that debris is a key and critical issue. Hopefully you have seen her report out there in the front before you came in. If you haven't had a chance to take a look at it, by all means, you should take a look at that, because certainly the work she's done on debris mitigation both makes a great deal of sense, but is also an important contribution to what it is we're trying to do and what really needs to be done, very much so. So congratulations, we appreciate it very much. And glad to hear it.
And the name is Sneha.
Yeah.
Great. Thank you, Dr. Wertz. Okay, following our program, it is up over, what's up next is our technical excellence award. So, this is in a yearly award we give to organizations for their technical achievements. Up first on the list is Equal Space, represented by Dr. Gary Lee. I'm going to start off with the recognition person and maybe okay.
Should I hold it or? Okay, awesome. So nice to meet you, everyone. I'm Gary Lee. I'm the Director of Government Business Development at Impulse Space. I'm very honored to be here receiving this award on behalf of the company. I was not involved in the engineering of this. I am an alien engineer, and so my background, I did my PhD at UCLA. I am local here. I worked in electric propulsion, a little bit in nuclear fusion, and worked at Aerospace Corporation for a few years before I moved over to Impulse as employee 47. Quick intro to Impulse before we talk about the Remora mission. Impulse is a 5-year-old startup. We were founded by Tom Mueller, who was the first employee at SpaceX. He started this company after trying to retire, and then investors dragged him out of his garage, gave him $30 million and said, go build a space mobility company. And so now what Impulse does is we build maneuverable space vehicles. We have 2 major products, one called Mira and one called Helios. Mira is a Esper Grande class spacecraft, so it's about 330 kilograms, the size of maybe this table, a little wider. And in the 5 years that we've been alive as a company, we've now launched 3 of them. So the Remora mission is the second commercial mission that we launched back in February of 2024. I think the year's right. No, February of 2025, that should be right. On these missions, we carry commercial payloads and we do many types of complex missions with our hosted payload partners. And so I do want to give recognition to Starfish Space on this Remora mission. They played a critical role in this. The Remora mission itself is a rendezvous and proximity operations or RPO type mission, which means that you use onboard navigation to get close to a target, and then ideally use closed loop navigation to get even closer. Theoretically, you could go and dock with such a thing, but it depends on what suite of sensors you have on board. And so with Remora, what you're seeing on this slide here, which we'll play in a little bit, the hardware on board our spacecraft is essentially a Starfish procured optical camera. It's just a single camera, so pretty lightweight as a sensor suite system. On more advanced systems, you might see an optical camera, infrared camera, laser rangefinder, LiDAR, and many more things. There was a single optical camera on this spacecraft, Mira, that we hosted. And essentially, we designed our spacecraft to have a containerized GNC architecture that could interface with external RPO kits, as we like to call them, that send our bus commands to change the attitude or fire our thrusters to perform these maneuvers. So essentially, you could stick another RPO kit on our Mira bus, and we could do a very similar type of thing. And so now to the slide that you see here, we call this fully autonomous RPO because in this case, we worked with our Starfish partners to basically commission their camera system. We looked at various objects on board, calibrated it, and then at some point, we let the RPO kit essentially take over. And so we stopped letting our operators command our satellite. We said, Starfish, go ahead and now let your camera and the computer on board tell our thrusters to do X, Y, Z burns. And we navigated from 10 kilometers. This is in a sun-synchronous low Earth orbit. We were dropped off on a transport mission. We went from 10 kilometers, point and closest approach, all the way down to 1250 meters, so 1.25 kilometers. And in the video, Ken, if you could play this one, you'll see this unresolved dot. This was our first spacecraft that we launched. This was the first spacecraft we launched back in November of 2023. So we essentially took our second spacecraft, put Starfish's RPO kit on there, and RPO'd with our first vehicle. And you can see it rotating here and start to resolve some of the solar arrays on there, which is pretty amazing. And so definitely an incredible feat of engineering from our team. Very low cost if you compare it to how traditional RPO missions have been done. And also spinning really fast now. It's pretty amazing. We still have communications with both of these vehicles, but this first one is essentially done. It's in an FCC compliant orbit, so deorbit in less than 5 years. No one worry. And our second one is still performing missions. You can see it getting larger and larger here. You can resolve the solar array panels. On the bottom right side, you see our thrusters on board firing. Just a small fun fact, we don't use toxic propellants at our company. We use green, non-toxic propellants, nitrous and ethane. Nitrous oxide is laughing gas from your dentist's office. Very accessible. You don't need bunny suits, hazmat suits to handle these things like a traditional hydrogen systems do. And so you can see those thrusters firing there. Those are videos from on board, so very cool to see that as well. And so thank you all for the award, and thanks for listening to a little bit about impulse and factor studies.
We also have another award in recognition.
We're giving the brief too. I get the whole vote.
Ken's very good about awards.
The votes, Jonathan, sorry. Thanks.
So we have our next recipient, L3 Harris, and it's like by Mike Flower.
Let me start sharing here.
So L3 Harris being recognized today for the design, manufacturing, and deployment of four stage rocket engines and key components on the SLS rocket and Orion spacecraft integrity for the NASA Artemis mission.
Yeah. Very good. Excellent.
You'll get it.
Yeah, I will get it for you.
Okay. All right. Thank you.
Yes.
Awesome.
Thank you.
Well, thank you, everybody. I'm super happy to be here, representing L3 Harris. I am L3 Harris, actually, really Rocketdyne, Aerojet Rocketdyne, and L3 is our latest who purchased us about 2 years ago. So, had the pleasure, honor of being involved in the latest Artemis mission, all Artemis missions. I wanted to tell you about that a bit. Why don't we go to the next slide, the video. It's our little teaser primary. So, just get up.
Okay, here we go.
That was our simulation, and the actual mission went about as close to simulation. Next slide, Ken. So my name is Mike Lauer. I am the general manager, program manager, RS-25 Space Launch System, formerly Adapted Space Shuttle Main Engine, and we are the core stage engines for the Artemis rocket. I have been with Rocketdyne up in Hill Park for about 30 years. And worked through various engine programs and space energy and nuclear. And I'm so happy to be involved in this mission and obviously our impact on the world and this amazing feat that we just pulled off that I'm sure you all watched. So it was pretty spectacular. So next slide, please. So the next slide is just about Artemis. I think you're all very familiar about Artemis. Artemis, sister of Apollo. It's an international collaboration. It's not just going to the moon and sticking a flagpole in and footprints and leaving. It's about a long-term progress to the moon. And ultimately, really, we are setting up for Mars. The Space Launch System rocket is some of its fundamental design characteristics are set for Mars missions, for deep space Mars, deep space. The Orion spacecraft, the one on here named by the astronaut crew called Integrity, is designed for deep space and deep space loiter and long periods of time in space. And so the Artemis is about that. And it's about multiple industries, not just NASA's traditional contractors. You would say I come from one of the traditional contractors that supplies NASA. My company has provided engines for Apollo. We've been to our thrusters and rockets have taken a spaceship to every planet in the solar system. We've been involved from Apollo, Space Shuttle, and today. And the new Artemis missions include new entrants like Blue Origin and SpaceX, bringing them all together to try to collaborate on, frankly, the most technically difficult thing that we have ever done. And if we go there and the lunar base and the new NASA administrator, it's an inclusive. We go with the world, and we go for all humanity. And so the Artemis mission, and we are just getting started. We consider ourselves part of the new golden age of space, and also creating an economy that we go to the moon. Kind of like what's going on the space station, but even more. Next slide, please. A lot of people ask, so why do we do this? Why do we go? Scientific discovery. The moon is like a history book of the solar system. You know, the processes on the surface of the Earth remove the history, the planetary impacts of the moon. It's all there. You can learn from that. In situ research utilization, human beings living distant on a different planet. If we truly want to be an interplanetary species, if we want to move out, this is the perfect grounds to do that. We believe that the economic benefits are far more than what we actually pay from the treasury. The inspiration of people. When we fly to the moon, we birth not only engineers and technicians, but we scientists, artists, authors, people who want to join with people to do very hard things and work together. These missions involve hundreds and hundreds and thousands of people, and when joining all those people together, people learn how to do this. And we in the United States, we want to lead in that. We want to lead with our partners, with our international partners. And there's also a national security aspect to this. People talk about the moon being the true high ground. And China has stated clearly they want to land on the moon before 2030. And so that is almost like the new space race we've been talking about. So we want to be there for our norms and processes and lead the rest of the world. Next slide. So Artemis. So the Artemis missions back in 2022, Artemis 1, an uncrewed mission that flew the Orion spacecraft around the moon and orbited the moon. It was about a 30-day mission. Came back, landed. Most important aspect of that mission, most important objective of that mission was to test the heat shield, because you can't test a heat shield coming back at 25,000 miles an hour in any sort of lab. You can test parts of it. By the way, that's 7,000 miles faster than a space shuttle. So it's coming in really fast. And that heat shield, you probably heard in the news, experienced some damage, and they were trying to. That was the fundamental reason for that mission. Let's learn how the heat shield works. And there's been a ton of work on that heat shield and proven successful. Same kind of heat shield that was actually done on Artemis 2 that just flew, but by changing the trajectory of the reentry, was able to control the heat loads on the heat shield. So Artemis 2, just fantastic. These are 4 individuals. That's recording my voice there. That's cool. Jeremy Hansen, Canadian Royal Air Force. Christina Cook, mission specialist. She was in Antarctica for many years. She has the record for longest female in space on the space station. She's also did all female spacewalkers, so she's a spacewalker. Victor Glover, Southern California native from Pomona, Cal Poly San Luis Obispo. He's also a naval aviator, an F-18 driver, and finally Reed Wiseman, who is the commander of the mission, also a naval aviator, and previously the head of the astronauts. These individuals are just fantastic people. I've met them. Their lives were on our hands when we flew them to the moon, and it's a huge honor to have taken them to the moon and back in Florida after we launched and went into the hotel, and Victor Glover's his whole family was there. And they were hugging each other and celebrating. And I said, "Are you guys related to Victor?" "Oh yeah, that's it's my dad. It's my." So we just flew him to the moon. So thank you. Next one. Here's a video rendition of the mission. So if we launched from the Space Launch System, did a couple of perigee and apogee raised burns, then the upper stage took us into a high Earth orbit, about a 24-hour high Earth orbit for them to do checkouts of the life support system. Super important portion of that, because before you commit to translunar injection, you want to make sure the life support system works. The abort scenario in high Earth orbit is within, maybe an hour or a day to get back. Once you commit to the moon, you are days from getting back. You do not want to go unless you know the systems work. And so we committed to translunar ejection. There was a number of orbital correction maneuvers that were desired. They weren't done because the trajectory was so accurate coming off the Space Launch System. We put them into an orbital insertion accuracy within 99.92% of the target. The two giant solid rocket boosters fired within 1% of performance and within a millisecond of each other from start to shutdown. Absolutely amazing. So the mission, I say, it did work out about as good as we could have hoped. And the amount of people that took to get prepared for all of that and all the aborts and possibilities and possible scenarios was just amazing. You can go to the next slide. Space Launch System, so it's the rocket, we call it America's rocket. We all own it. It's not owned by a billionaire. It's all of ours. It is. We are not fully vertically integrated. There's 1,100 companies across the country that build parts of this thing. 28,000 jobs. I mean, there's like 94,000 jobs involved in the whole Artemis campaign. So yeah, the rocket is a magnificent. It's 8.8 million pounds of thrust at takeoff and goes for 2 minutes, and then the solid rocket boosters separate, and then we go another 6 minutes and take all the way from the ground all the way to space with the RS-25 engines. Next. Just what shows how the rocket's made out. So L3 Harris, the company I work for, we're on this vehicle actually tip to tail. So the very tip, the launch abort system, the jettison motor that actually fires to pull the launch abort system off the top is made by L3 Harris. The crew module, the Orion crew modules, the thrusters are actually made by L3 Harris up in Redmond, Washington. The European service module has thrusters on board that are made by here in Canoga Park and up in Redmond, Washington, the Orion main engine. We did the RL-10 engine in our West Palm Beach facility that was part of the upper stage. We have avionics up and down the rocket, both in the core stage and the solid rocket boosters. And the part that I'm responsible for are the 4 RS-25 engines at the bottom. So we're up and down that vehicle, and lots of partners involved. You can see all the people that are involved. So before there was Artemis, there was the space shuttle. About 50 years of history and development. The space shuttle main engines. When we finished the space shuttle program, we had 16 engines left from the space shuttle. Reusable engines, we recovered them and we stored them. And then you go to the science center, right? You see space shuttle there, and these are simulated engines up in there because we recovered those engines. And then what we did is we updated them, and we pulled all the electronics off them and updated all the electronics and stuff that's advancing really fast. We insulated them because the proximity of the solid rockets to the motors is way closer. So the thermal loads on that system are way high. So we had to insulate, update electronics, harden, and then test the engines to even more power levels. So we fly with higher power level than we did on the space shuttle. The space shuttle would launch at 104.5%. On Artemis, we're launching at 109. On Artemis 1, 2, 3, and 4. On Artemis 5, we're going to launch at 111. So we kept squeezing more power out of the engine and improving its reliability and performance. We do all that at Stennis Space Center on the test stands at Stennis Space Center, where we'll test every engine we build before we go fly with humans on it. Thanks. So here's some good pictures from, this is a nice shot when we're testing any one of our engines at Stennis. And what we're doing is actually testing the gimbaling, so the way the vehicle steers is big hydraulic actuators gimbal those engines, so we test that on the stand. There's Jeremy and Christina in our plant up in Canoga Park looking down one of our nozzles, the back end of the space of the vehicle there. The nozzles are amazing. We pump liquid hydrogen through those big bells, those rocket engines, so it doesn't melt down. And then we are now prepared, about to ship Artemis 3 engines. We have them ready for quite a while. So if you didn't see in the news, the core stage, the big orange tanks arrived at Kennedy Space Center a couple of weeks ago. In a few weeks, we'll ship the next engines down there. We'll be building that stack. Northrop Grumman has been shipping solid rocket booster elements by train to Kennedy Space Center right now. And so we'll see that stack start to come alive. And so the next mission, Artemis 3, which was recently changed to be in-orbit rendezvous with human landing system, the first human landing system that is brought to the table, either Blue Origin or SpaceX. And that will be a rendezvous in low Earth orbit to do rendezvous and proximity operations. And then Artemis 4 will be the actual landing in Artemis 5. That's all targeted to try to get done before 2028. So the current administration is pushing to let's get this done. So we're excited about that. And back in the factory in Canoga Park, we're building engines all the way out to Artemis. Gosh, I think we're out to Artemis 9. So we're producing because our goal is we're going to support this mission and make it true that we really will have a sustained presence on them. That's all I have. Thank you very much. The time for questions or?
Yeah, question here for. Oh, that's all.
Thank you. Yeah, I was doing. Any questions? Go.
How much of those engines are scavenged or salvaged from the SPS?
Well, the first four flights are the 16, so four per vehicle, and they are straight from the space shuttle. And in fact, what we just flew on Artemis 2 had parts on it from SDS 1, 1981. And so we have still inventories of parts to go back, and then the ones we're building for Artemis 5 and beyond are all brand new, all brand new. And one of the big problems was restarting the supply base to be able to make those things. And you would believe it or not, it's very hard to make what we used to make in the current supply base. Yes.
Mention 2030. What is our biggest challenge to meet that be?
The human landing system. The human landing system. How are we going to get a lander in time? If you study Apollo history, one of the hardest developments was the lunar module. An amazing feat. I mean, the lunar module is just absolutely amazing. Right now, we are SpaceX and Blue Origin are trying, racing, and they've got some very complex architectures to be able to have a lander, like in orbit refueling, 15 flights of refueling before you go to the moon. So there's a lot of complexity. So the biggest thing that we have is the lander.
You said it's hard to build what we used to do. Can you expand on that?
Well, believe it or not, there's a craftsmanship involved that is in making some of these super highly complex parts. And frankly, we've gone out to industry and to people who used to build this kind of thing, and they have chosen no longer to do that because you can make more money on easier, simpler, larger, batch buys of things. It takes a lot of craftsmanship and specialized work in order to make a lot of these parts. And so, yeah, we've had to find people that are willing to work with us and redevelop some of those skills, even though we're given them essentially the same drawings and specifications and all those things. So that's been a real challenge. But part of the mission of it is to build our capability in the country to still do this kind of thing, to do the hard things. That's why we're doing it. Yes.
What's the lead time for ours 25 engine?
Ooh.
What's the production rate?
The production rate is, so it's depends if you started trying to build them during the pandemic. Interestingly, during the pandemic, a lot of when the aircraft industry sort of throttled back, we suddenly got we're first in line getting a lot of basic metals and things like that. It takes us about 5 years to make a RS-25. And that's a challenge because if your product, government-made product, takes longer than a presidential administration, that's not a good place to be. So one of our main goals is reducing the lead time. And so we're using a lot of additive and things like that. Our new version of the engine, we have additive manufacturing. We're really trying to reduce the lead times and speed things up, reduce part count, all of it. Great. Okay. Oh, last question.
Does the fact that you're not, these are single-use engines, is that making a significant reduction in cost?
Yeah, we have been able to take advantage of the single use. We won't have to, instead of 55 missions, which Space Shuttle was designed for, we're able to, reduce some of the margins that we would have had because of the long time. So yes, we're taking advantage of that. Yeah. But the engine really was the first prime reusable engine. It's just the vehicle is an asset. Okay, thank you.
Thank you so much, yes. All right, so up next, we have membership recognition. So for this recognition, we want to recognize members who have advanced their membership within AIAA to higher levels. That's one part of being a part of this organization is, advancing as your technical expertise increases, you contribute to our industry, you get recognized. So we have a couple members who have taken the next steps. First, I want to recognize our fellows, of which we have one, and of which we are represented actually, Dr. Aylor. You should please join me up here to recognize your award. Yes. You are an AIAA fellow for the Spice Conference. Back your Texas. Thank you.
Congratulations. Thank you.
All right. Up next are associate fellows. So I believe this is for making notable contributions to our industry, aeronautics or aerospace, and also must be a member in Fulton's team. So first, I want to recognize Kevin Bell.
You want to stand before you?
Yes.
Oh, sure. I'll say a few words. I say, is it Sneha? Do I say that right? Sneha. How many, so raise your hand, where are you sitting at, and how many other students are in the room? Raise your hand if you're a student. Okay. Wow. I mean, Bill, Gary, and Mike? Yeah. This is what the industry offers. All three are just amazing contributions to what the US is about in the space program. I'm awesome to see the students here as part of AIAA. Sit with AIAA offers you a great insight and look into the industry. And I'm hoping you can see the different trajectories you can take a career in aerospace industry. We need you both for exploration, for maneuvering and enabling, I'm gonna call it space superiority, and protecting the planet. All of those are just absolutely critical. So thank you for being here.
Okay, up next, our associate fellow, Mark Olmos.
Thank you.
Congratulations.
Great. I really want to thank my wife for being here and for all the hours she had to sacrifice her time and so for my very long hours and being away from home and things like that. I'm sure a lot of you can relate to that. I want to thank my mentors, Stephen Satterley, who nominated me, Doctors Luke Castles passed away. He was a great guy. Dr. Tony Lin, Dr. Jim Fidali, Dr. Shivananda.
who really influenced my life quite a bit. I've had the privilege of working with a lot of our young engineers with Northrop Grumman, and a lot of them at Roy, Utah now. And I'm really impressed with a lot of the young engineers and their capabilities. And I really appreciate the young people that are interested in aerospace now. And I think the industry is in really good hands for it. Thank you.
Okay. We've got some other awards that we'd like to also present by our AIAA technical committees. First up for best paper in aerospace design and construction group, digital twins of additive manufacturing parts for fatigue life prediction, Leyland Schmeisen.
Sure. And so first of all, thank you. I'm really honored to be here to receive this award today. I want to especially also thank my co-authors on the paper, Dr. Vinay Goyal, Jacob Rohn, and Dr. Kevin Q. They were all, instrumental in making this work happen. I'm just one of the authors on this. This paper is really about a transformative technology in the industry. It's about additive manufacturing and use of digital twins. And I just want to say, I guess, that aerospace and our department are more or less committed to continuing to support the aerospace industry as new transformative technologies continue to transform it. Thank you.
Okay, we have another technical excellence award that we'd like to recognize. This one is in the category of propellants and combustion award for outstanding contributions in studies of planes, including plane theory and fundamental frame property measurements and simulations, especially at engine relevant conditions. Professor Focus.
Thank you very much. It's a great honor to be recognized both by AIAA and the LA section. While we keep the lights on and we see these amazing people here sending vehicles to the moon and the beyond, some others, including myself, we're doing measurements at a very fundamental level. The reason is that until a few years ago, maybe 5 years ago, software was, computations was one of the main design tools we had. Now we have AI. And I was telling here my friends at the table that I just came back from Detroit, and a higher up person from NVIDIA gave us the talk. And he said that he was explaining how the new chips they have, they work so well, etc. But then the question was at the end of the day is, what do you do with this technology? The only way to, he said, of course, we know that, is to have data. So what I'm doing is basically producing fundamental data. I'm nowhere close to where you are, guys. And eventually, one day, AI or CFD, I guess, would be able to help you with design. Thank you.
Okay, yep. Can you just inform me of another recognition that we have in our program? They're not here, but I will read the title anyway. The AIAA Wright Brothers Lecture in Aeronautics Award. The lecture was The Emergence of Hybrid Electric Aircraft by Dr. Susan Yee. Okay, moving on with our program here, there's a couple notable anniversaries of membership. Again, if you refer to your program, there's a long list of names of AIAA membership, 80 years, 70 years, 60 years. A lot of those individuals could not make it today, but we do have one recipient who is here with us today. Just made it to 25 years, and my number, Dr. Ken Louis.
Oh.
Thank you. It's my great pleasure and honor to join AIAA. It's a great personal feeling of a lot of things. When I joined in 2001, that's when the September 11 occurred. And also at the time it was really a project for Mars settlement. And I started to read a book from Michael Patton and also AIAA courses. That's how I got started. So I highly encourage young people to join the end of it early. The longer you stay, the more recognition you might get.
I've nominated you for every award.
Yeah, I can say come to Michelle. So the people supporting here, all the council member, Matthew, and Dr. Middleman, and also everybody here. Dr. Ada, we have your presentation, talk before, and Kevin helped us for the regions business. So everybody here, we are family. It's a great friend of family. And Lee Jensen and everybody here. Thank you.
Okay, up next, more recognition, this time at the national level. For this, every year, AIAA, if you don't know, is split up into different sections. AIAA happens to fall in the very large category, just due to our membership size. So we compete with other sections across the country for awards. And in our category, if you refer to your programs, we have a list of different awards that we won, stemming from young professionals to STEM K through 12, and the Outstanding Activity Award, the Outstanding Section Award. In that list, you'll find that the people that are being recognized are our council members, which are sitting right over here. Our council members devote their time to AIAA, to running this thing. So it feels good to recognize everyone sitting at that table. There's a couple third places, first place, but I'm really proud of the Outstanding Section Award because that's one award that all the very large sections compete for, and that just shows that what we're doing here is good and we're being recognized for it. So great. I want to move this into more of like a local recognition for some of the events that we hosted throughout the year. So for this first award, I'm going to ask Jeff if we can come up here and help with the presentations.
The reason I'm doing this is because Luis is actually winning this award and being in good taste for somebody else to present. One thing I'll mention, the LA section has a very good track record of winning awards at the national level, including Best Activity Award year after year. And that contributes significantly to being named the best section as well. So congratulations to you and the LA section for all the awards, and to you in particular for winning the Best Event Award.
Thank you. Thank you, Ken.
All right.
Okay.
I'll say a few words.
Yes, absolutely. Yeah, for some context here. So I help coordinate our student mini branch. Every year, this section hosts a student mini branch where we invite high school students, or sorry, not high school students. The 4 college students, 4 universities in our jurisdiction, USC, UCLA, Cal State Long Beach, and UNLV to basically take an industry tour and then present some of the work that they're doing at the collegiate level, whether that's participating in DPF, building rockets, whatever it may be. We get all of these students together in a group, give them the industry tour. They get to meet people, they get to have their interviews reviewed, resumes reviewed. And they get to learn more about what they do, since they may not, interact much outside of this event. So this particular year, I was able to get my employer, Jet Zero, to host this conference, and the students had a blast. So it was a great event, good all around. So moving on. Oh, yes, and yeah, Ken, thank you for reminding me. Ian is also being recognized as he helped with setting this event up as well. Thank you. Thank you so much. All right, thanks. Thank you. Thank you, Ian. Okay, up next, we'd also like to recognize another event. This one was very special, as we were able to host a very special individual who had a huge role to play in developing James Webb. And for this event, we want to recognize Dr. Bouchel for helping moderate, for for bringing Dr. Ehrenberg along and promising that he's gonna have a good time. Yeah. So I'd like to.
Oh, thank you very much, Luis. I can't believe I'm getting an award for moderating an event. It's really not well known that I'm actually Ehrenberg's agent, so I arrange things for him nationwide. But I do want to say something serious. One thing that warms my heart is seeing the next generation running the show here. So Luis, Ian coming up to get his award as well. Some sections stagnate, but I think one of the true gifts of the LA section is our succession plan. So thank you. Congratulations.
All right, up next, late last year, in 2025, Dr. Madi came to us with an idea of hosting a very special conference webinar where he invited a lot of his colleagues to talk about space architecture, space, everything related to space. So, Dr. Madhu, we'd like to recognize you for your contribution in that event. That was awesome.
I have no idea that.
Would you like to say a couple words about that?
Well, what can I say about, Christmas is a very special time. And I thought it was a very good idea to get some people together. And as usual, I got in trouble because everybody wanted to talk. And usually, Ken will tell you, we do not more than not more than 3 of them. But we ran to 68. But everybody had a good time. And the things people don't tell you about the aerospace community, particularly the astronautical community, is we have a lot of fun. We have a lot of fun, not only with the technology of it, but very much knowing each other. And I'm so happy to see the youngsters in the back, and I'm hoping you all do the same and enjoy this ride, because 50 years will go by in a flash. Thank you so much. I wanted to also mention something about Bill Taylor. Many of us are very understated. Now, Bill taught me a lot about planetary difference. So yours truly ends up blabbering some funny things in his August conference in Italy. And following that, the young people, 20 to 30, in that range, they thought our idea was the greatest. So they called me into the International Space University. I don't know if any of you have been there or I know, no mess. And, oh, you were at that class too. So I go in there and, I'm the viewing victim. So we are sitting there and, I was given, control of 37 people from all over the world. I had no idea who they were. I quickly found out some of them are from the adversaries, defense organizations. Well, good. We had the class, we continue over the weeks. And the question came, Bill, who will control? Who will push the button? Oh boy, I don't know who was there, but that was hell. You know, there are people from China and South Korea and other places. They said, no, you cannot have the US control. So these are the kinds of things that we need to talk about. And I'm so happy to see Bill and his folks here discussing planetary wisdom. Thank you. I took too long.
All right, so next we're gonna ask the council members to come up here and receive some flags or some awards here. Up first is Gary Moore. It's recognition for your lead and moderation of our AIAA alumni meetings that we all love so much. We want to say a little bit more about that.
Yeah, well, one of the interesting things about the career is just how many things we have worked on over the course of the career. And the stories that one can tell, both about the people and the technology, and the things that you wish you could do now. It's just the thrill of the camaraderie and the opportunities to recall some of the great steps of the last, in my case, more than 50 years. So, thank you.
Great. Thank you, Gary. Okay, up next is Lynn Jensen for his contributions as our council treasurer and his invaluable work on her council as well.
I think this is probably an award for the least amount of effort. The treasurer is very important.
I don't know, man. Treasurer work
In this room by far, but I worked at Northrop Grumman for 44 years, and before that with the CIA and also on the Minuteman missile guidance system. And I can say that it has been a dream job every day of that time. So I'm so grateful that I just happened to be in the right places at the right time, and this is one of those places. LA section, so thanks so much. Thank you.
Okay, up next, Daniel for his work as our public policy chair.
I guess a couple things. So, so I'm a public policy chair. My background is in flight safety, aerospace safety. So it's a lot of direction. But I would like to say, well, I work at USC, and one of my colleagues is a contractor.
Anybody else want to go to US and back?
One of my colleagues is a contractor with the university. It's also a major misstep investigator for NASA. So I say thank you for not making our life difficult. And like I'm actually going out to Creek. A lot going on, not in that space with manufacturing space, certification space. So thank you.
That's happy to turn the camera. Sure, yeah. So you have someone, council member who's joining us today virtually. Her name is Arpi Osepkin. She's our STEM outreach chair. an educator herself. RP, can you hear me?
Yes. Thank you so much. It's been such an honor to hear everyone's accomplishments this year, and it's such an honor to be part of this wonderful section. It's filled with superstars. Thank you so much.
Thank you, RP. Okay, last but not least, we have Dennis, our Career and Workforce Development Chair. You have a very special event coming up.
Yes, I.
Right, yeah, this particular fund is for your donation to our section.
Oh, okay. Thank you. Yeah, I've been watching what Ken's been doing all of these years with all of his outreach, so I thought I'd donate some models and some technology that kind of help him out since he's been doing such wonderful work, mainly by himself. So great work. Thank you. And also, I really should use the program because I didn't even know this.
For context,
Thank you. Thank you. Thank you.
okay, yes. For context, Dennis will be presenting May 16th talk on hypersonic vehicles, specifically the NASA X-43 program. So, if you're interested, please register. Also, Ken correctly pointed out, we have a new member on the team. His name is Andrew Velasquez. He's our current secretary. Andrew, would you like to come up and say some words? Your mic is on.
Just wanted to say a really big thank you for Ken and Luis. Everybody mentioned the camaraderie that happened within the organization, and coming out of college, I found it first a little difficult to get myself into the workforce, and the AIAA really gave me a really solid footing to really find myself, solidify myself, and make that breakthrough where I'm currently at right now. So absolutely a big thank you for both your support.
Thank you. Okay, up next, I'd like to invite Ian, who's going to present some awards for UCLA.
Thank you. If I just announce or just.
Yeah. We have lights for them.
Okay.
Yes.
They have a presentation. I mean, a presentation.
Okay.
Hi, you guys don't know me. My name is Ian Fabio. I'm the educational chair for the AIAA Los Angeles section. My job is basically to keep the 4 student branches of our section: Cal State Long Beach, UCLA, USC, and UNLV intact, and just like be liaison to them and be like the main communication, just to keep the students and the section like having a good relationship with them. So yeah, so that's basically that. We're here to recognize the AIAA Design Build Fly team of UCLA for their accomplishments. And so we're here to give them medals. So if anyone from the UCLA Design Build Fly team can stand up and reach a reward.
Oh, yeah. Congratulations. Thank you. Oh, the names. Oh.
That's
I didn't know they had names. So. For me to get for yourself.
Round of applause, everyone. All right, and I understand they have a presentation for anyone to present. So I'll give the microphone to the UCLA Design Compliance team.
Thank you.
Thank you so much. It's an honor to be here, guys. We're Design Build Apply at UCLA. My name is Sohan. I'm the incoming project manager for next year.
How about you? I'll be the vice project manager for next year.
I'm Kelsey and I'm the retiring project manager.
My name is Peter. I'm the chief engineer.
Cool. So we just have a brief presentation prepared about our club. Thank you. So a little bit about us and what our mission is. So for one, what we want to do is promote the application of theoretical engineering skills that we learn in our classroom. Obviously, there is sometimes a lack of actual hands-on experience that we can have just through classes only. So through our club, everyone gets a chance to actually work on hands-on stuff, get to actually build a remote control plane, so on. And part of that, again, as a consequence, you guys should develop technical and leadership skills as well. And obviously, one of the best things is we get to represent our school and our UCLA Samueli School of Engineering at the international competition every year. So on the left, this is part of our team of 34 that we took to Kansas this year. And you can see our plane on the bottom as well. This is actually not our entire team. We have a lot more people as well that we just didn't take everyone, unfortunately, but that's our team.
Yeah, so a bit about the Design Build Apply competition that we attended. Each year, AIAA hosts a new competition with a new set of rules, and over 100 teams compete. I think like around 183 apply to compete, and only 100 get to compete, which is pretty cool. This is this year's competition, which took place in Kansas like 3-4 weeks ago, and that's our plane called Goose, full name like Goose. Yeah, but if you. All right, so speaking a little bit more details about the competition itself, this year there were 4 missions that our aircraft had to complete, which you can see listed out here. Mission 1 was a proof of flight mission to show and demonstrate that the aircraft is safe and can do the missions. Mission 2 involved carrying a payload of passengers and cargo, which were this year represented by little rubber duckies as well as little hockey pucks. That's where the inspiration for the name or plane came from. Up next, we have Mission 3 that involved deploying, towing, and releasing a large banner. You can see a picture of our banner right here. I forgot to mention as well, Mission 2, we got points based on the number of payloads that we could carry, as well as the number of laps we could complete with that payload. Mission 3 involved the size of the banner, so a larger banner would yield a higher score, and also more laps completed would again yield a higher score. And then finally, the last mission was the ground mission, where we demonstrated the loading and unloading of all of our payload from our aircraft. And we got points based on how quickly we could do that. Now, specifically, our strategy this year, kind of a piece of this is picking the best strategy. We specifically prioritized Mission 3 and ground mission. So we actually carried the minimum payload of just 3 passengers, but that allowed us, one, to create a very aerodynamically streamlined aircraft to show an especially large banner for Mission 3. And also improved our time on the ground mission so that we were able to unload and load the plane extremely quickly.
So here we have videos of our Mission 3 and our ground mission, like Peter described.
I don't know how to play this.
Someone press it.
Yes.
Thank you.
Well, this is a PDF file.
It should, I don't think it should be.
It should,
yeah, it should take you to like a Google Drive thing. There you go.
So this is a clip from a live stream that AIAA provided this year competition.
Here, which is the biggest one that we've seen. For the people at home watching, that doesn't make any sense there. We have a 6.28 meter banner from UCLA here. Pilot chute for, for parachute.
Like a drone.
Yep.
And cleaning out.
Oh, very
Great
nice.
deployment. I think that's the smoothest one we've seen.
Yeah, that was nice.
Great engineering on that release.
Yep.
Tunnel testing, they did flight testing.
Yeah.
Of course, Southern California, nice place to test.
Yeah.
One of the teams, oh, there we go with the release.
Yep. Banner's dropped.
Just missed the photographer.
Yeah, almost took out the photographer over there.
Okay, and
circling around.
Land the other way. By the way, you are allowed to land either direction on this runway.
Oh yeah. Oh.
All right.
Putting some work in that suspension design. There you go.
Good spring.
Yeah.
Very happy, UCLA team.
If I
I have to know the landing was a dead stick landing. Our pilot's usually better than that. But yeah, so that was part of our 5-minute flight. I didn't want to shoot the whole, but yes, those were the key moments. And then this is our ground mission. So the point of ground mission, like we said, is to load and unload our passengers and payload as quickly as possible, as well as our banner. Are you able to click that video as well?
Go. Controls. All right. Puck steps and banner. You ready? 3, 2, 1, go. All right, controls. Lift up for your deployment. Deploy. Drop. Drop. Let's go!
So that ground mission time was just over 11 seconds. We were super impressed with how much we were able to accomplish with that throughout the year. I should also note that there was a lot of freshmen working on that. So very impressed with our team for picking that up really quickly. And then here were the results of that competition. We placed 3rd overall internationally, so we were super excited about that. That was our first podium finish ever at UCLA. And we also got 11th place on our design report.
Yeah, and of course, as engineers, we're always pushing higher and further. Now that we've proven that we can be a top team on an international stage, we're of course pushing for the ultimate prize, which is first place. Our goal for next year is, of course, first place overall in the competition, as well as first place on the written component, the design report of the competition as well. We do have, of course, many improvements in mind to our aircraft and to our process to accomplish that. Next year, we're going to be one of the only teams in the competition to explore resin infusion for our composites, as well as a number of different weaves, tows, and other analysis on top of that. Similarly, we're overhauling our entire propulsion and aerodynamic sizing processes. We're including much more analysis beforehand, as well as a series of new testing, including dynamic thrust testing of our propulsion system, and so on and so forth, with many, many other technical improvements.
Yeah, huge thank you to our sponsors, donors, alumni, and faculty members who can help make this happen. If you guys are interested in any more information or want to sponsor, that's our email, and you can also check out our website. Again, huge thank you to you guys as well. We couldn't have done this without your support, and we're really happy and proud to keep going, be better. Thank you.
Thanks, guys. Great.
Okay. Up next, I think I'm going to turn things over to Arby, who's going to present.
Oh, no, the Region 6.
Oh, yeah, sorry, I'm getting ahead of myself. Actually, I'm going to turn it over to Jeff, who's going to present Region 6 Best City Neighborhoods.
Well, hello again. One of the things I do for the AIAA is serve as Deputy Director for Education in Region 6. And the main purpose of that position is to oversee a student conference that's held every spring. This year we had it in Cal Poly, San Luis Obispo. It's a great event, it's a lot of fun. When I say the student conference, it's not just for students to present. They organize it, run the whole thing, and it's a great learning experience for them, I'll put it that way. They have a great time. So the LA section, as usual, did very well at this conference. We had more winners from our section than any other section in Region 6. So congratulations again to the LA section. By the way, before I announce the awards for the folks that are here or online, I want to mention that we have not yet chosen a location for next year's conference. That we had a university that had signed up to do it, but unfortunately they had to bow out. So we are actively recruiting. We have a couple of universities that have indicated some interest. I would love to have it in the LA section for many different reasons.
Send a note to USC and stuff.
I will. No, we've been kind of, looking at that behind the scenes. That would be a wonderful choice. We would love to have it there. It's in the middle of the aerospace world. We would have no difficulty getting judges. And it would be wonderful to have it back here in the LA section. We haven't had it here since a few years ago, but there's a familiar face online, Gregory Schechter. And I should mention that we were the first region to have a high school paper. And I was told point blank by other regional directors, you're out of your mind, high school, you're kidding. I have to tell you, I was deeply offended by that myself. I went to high school, international sciencer guy, that kind of thing. I said, you don't know what you're talking about. These high school students are brilliant. And I was so happy at our last meeting, national meeting, this guy said, I know that I gave Region 6 a hard time, but we actually had a high school competition in our region for the first time. Those kids are amazing. I couldn't believe it. So they truly are. So, and so I'm very happy to recognize Gregory Schechter, who is online. He took third place up in San Luis Obispo for an amazing paper on a novel method for reorienting CubeSats using non-commutative internal motions. When I saw the title of this paper, I said, can you actually do that? And he was able to show you can. So congratulations again, Gregory. Would you like to say a few words to the audience here?
Yeah, thank you so much for this opportunity. I'm sorry I'm not able to make it in person, but I'm so grateful for AIAA for this opportunity and being able to go down to San Luis Obispo. I learned so much, and I'm also very grateful for the judges' feedback. So I have a lot that I can improve upon if I'm to continue my project. And I also love the opportunity to see all like the campus of Cal Poly SLO, especially the wind tunnel and all of the workspaces that students use to make projects. That was very inspirational for me. So thank you so much to AIAA for this opportunity.
It was our pleasure. How did your talk go to the Orange County section?
I'm sorry, do you mind saying that?
No, never mind. Never mind.
That's not for you.
I thought you were the high school student that gave a talk to the Orange County section at the ASAT conference. So that must have been somebody else.
Yeah, I think that's.
Okay, sorry about that.
Thank you.
Maybe it's time for somebody else to take over as Deputy Director of Education. All right. We have some winners here in the audience with us. These are from basically the undergraduate categories. There are two undergraduate categories. One is for an individual undergraduate winner, and that's Giselle Frisbee.
I know that.
Yeah. What's that?
Exact.
Yes, that's the one with the exam. Yeah, sorry about that. But we have Nicholas online as well. Nicholas, we have the wrong title.
Oh, sorry.
Yes, but anyway, Nicholas, congratulations on your award for second place in the team category. Would you like to say a few words?
Yes, yeah, a small correction. I believe it was first place in the team category.
That's what I thought. I was looking at, yeah, no, thank you. Thank you. I was looking at that. I thought, USC won all of the awards.
Yes, yes.
But you guys, you were number one, so
yes.
You got the program right there.
No, I will say yes. Yeah, USC took all three places. I think the other two teams aren't here today because their members are from out of state originally, so they aren't part of the section officially. But a huge credit to our advisor, Dr. Matthew Gilpin at USC. He advised all three teams, so all of us credit him. I also want to acknowledge the other two members who also couldn't be here today. It's finals week and commencement at USC, so a huge mess. So my apologies for not being in person as well. But I want to thank my team members, Angelana and Nikitas Klapsos, also for helping with the project. And lastly, I want to thank AIAA for putting on this conference every year. I was at the one last year at UCI as well. Really enjoyed it this year and last year as well. So huge thank you for AIAA for the opportunity to present at the undergraduate level.
Well, we're so happy you did it. Thank you. I put misdeeds on the old word, but anyway, we're so happy that they were able to join us. Yes, okay.
All right, thank you. All right, so up next, we have some high school students on board that will be presented by Harvey.
Where's RP? 1 second. Wait for her.
Okay, I think everybody's here. Perfect. It's so fun to see technology working. So perfect. Thank you, everyone. My name is RPO Sepian, and I'm the K-12 STEM chair for the AIAA Los Angeles section. I've had the privilege tonight to spotlight all the various honors and awards for students in our area. Again, a big congratulations to Sneha for winning the James Word Scholarship. And we'll move into the STEM K-12 Student Awards and other recognitions. Tonight really is a celebration of student curiosity, innovation, perseverance, and achievement. These awards recognize much more than a final project.
You like Connor?
They represent hours of research, problem solving, revision, creativity, and the courage to take on these challenging ideas. So just to go in order, as you can follow along in the program, our first category is the Aeronautics Award. This year, we recognize Charles Chu-K-Lu from Palos Verdes Peninsula High School for his project entitled A Novel Adaptive Landing Gear Design to Reduce Stress During Crosswind Landings. I don't think Charles was able to make it tonight. He had a competition to attend for another event at school, but we do want to honor and recognize his outstanding work and achievement. I do believe Connor is online with us tonight. He also won this award. He is from Palos Verdes Peninsula High School. His project was entitled Controlled Magneto-Hydrodynamic Vortex Dynamics, driven by Lorentz forcing in a quasi-two-dimensional fluid. It's a handful. Connor's joined tonight on Zoom. I'm not sure if he can unmute if he wants to share a little bit about his project. Ken, is he able to? I'm not sure if the students can share.
Okay, 1 second. I think he's trying.
That's okay.
Oh, he got it. He had it.
Perfect.
Oh, we can't hear you, Connor. By the way, Analia is also online, but she's somehow not in the panelist area, but she can speak. She has a microphone.
Oh, perfect.
Still can't hear you, Connor. Not sure if it's on. I don't think it's on our end. Maybe go with Arnav first.
Sure. Let's we'll come back to you, Connor. Don't worry. That happens to me every day online. The next award we are pleased to recognize is the Astronautics Award. This goes to Arnav Garg from Palos Verdes Peninsula High School for his project entitled Flare Pin, a weak form physics informed neural network for solar flare forecasting. Again, congratulations to his outstanding work in space science, physics, and technology. Would you like to share a little bit with us, if you're able to? Arnav?
Oh yeah, hi. Thank you for this opportunity. So my project this year focused on improving solar flare forecasting. So one of the biggest challenges is that inherently data is very noisy. And to fix this, I developed this weak form approach that shifts the derivatives from double order to single order. And this basically reduces noise and adds physical equations into the picture. But yeah, I just want to thank AIAA for this opportunity.
Wonderful. We're so proud of you, and thanks for joining us tonight. I know it's a school night and there are so many exams and finals, but it's that dedication that we really respect and want to wish you all the best. For the General STEM Award, as we move on in our brochure and program tonight, this year's recipient is Analia Henderson from Palos Verdes High School for her project's very creative one. I read through it, Adaptive Wireless LED Illumination Systems for Real-Time Orchestral Synchronization. So Analia should be online with us, I believe, and her project is a wonderful example of how science, technology, engineering, the arts, and creativity can come together in a meaningful way. Analia, if you're able to, you want to share a little bit about your project with us?
She's here, yeah.
Sometimes I think it's hard for them. Does she have let's see, permission to talk, I think?
She has a mic, but she didn't turn it on.
Oh, that's okay. Her project was really amazing how she was able to connect a lot of this illumination through LED and music. I remember she had beautiful violins and different instruments. So if she's able to join, we'll be happy to hear from her as well. And if it's okay, we'll go ahead and recognize the students from the AIAA SSTC National Middle School Essay Contest. This year's theme invited students to explore how space images have evolved over time from early sketches and telescope photography to modern spacecraft, space telescopes, and advanced imaging technology. Just as we heard the speaker present about the Artemis mission, really brought so much of it to life tonight. The Los Angeles first place winner, whose entry will move forward to the National SSTC Essay Contest, is Deb Gupta, a seventh grader from Rio Norte Junior High, for his essay entitled First We Photographed It, Then We Stood on It, Now We'll Settle It. Very clever. Deb's essay captures the journey of human curiosity from early moon photography to the future of lunar exploration. One of the most memorable ideas in his essay is that space photographs show, quote, both memories and growth, reminding us all how far curiosity and innovation can take us. And we're super happy that he's here tonight, I believe, and with his family. And we want to thank them for traveling. I know it's quite a distance to make it down to LAX and making the time to celebrate. You know, it's moments like these that we remember as we look around the room and appreciate all the people that mentored us, like his parents and his teacher, Miss Anastasia Smith. And again, we all want to congratulate you for taking so much effort and writing such a beautiful essay to represent us.
Thank you so much. This is really like a wonderful opportunity, and I'd like to thank AIA for this opportunity. And at like such a young age, it's seventh grade. It's like so incredible to be able to like gain exposure to something I'm so passionate about. And just being here like so inspiring, seeing all these wonderful people was so influential in our journey back to the moon and beyond. So thank you so much.
And in a few years, you're going to be here too, telling us all about amazing things you're doing with your life. Time goes by so fast. The next one is the Los Angeles second place winner. It's Arav Raval, a seventh grade student from Palos Verdes Intermediate School, for his essay entitled Pillars of Creation. Arav's essay explores how images from the Hubble and James Webb telescopes have helped scientists better understand star formation. He also shares a wonderful quote from his essay, Newfound Appreciation for Technology in Space, and a sense of excitement about what the future will reveal about our universe. Arav is also here in person, I believe. He's able to make it up there. Beautiful. With his family. We want to thank you again for making the effort to be here, which means a lot to all of us. Along with his family, Arav's teacher, who's Ms. Wikata, is mentoring him and encouraging him. And we really want to congratulate you and thank you for participating with us and representing us so nicely.
I also want to thank AIA for creating this opportunity and recognizing me for the essay contest. I hope that I will be able to be here to inspire new young kids like me in the future to do well and continue learning about scientific and very interesting. Thank you.
Wonderful. And Ken, are there any other of the students that joined online that want to come back, Connor or Analia? Were they able to come back? Not sure with technology sometimes. We have to be a little flexible.
Connor, can you hear us? You are a panelist. Let me see. There, yeah.
I think we have his video. Connor, you want to try your audio?
Hello?
Yeah,
Yes.
we can hear you
We can hear you.
perfect. You want to tell us a little bit about your project?
Oh, yeah.
Sure.
Thank you for this opportunity. My project basically entails using magnetohydrodynamics. That's like the interaction between like magnetic and electric fields, in to create like a Lorentz force in order to try to like move fluids, which I use like conductive water, basically just make water mixed with salt water, and I tried to make like vortices that I could like easily control using these like magnetohydrodynamic forces, so that I could just kind of make it more replicable, and so that like constant conditions can be like observed even in multiple trials.
That's wonderful. Thank you so much for sharing that and for all your hard work and continuing on with your studies. You had earned the Aeronautics Award for our division. So thank you so much for being here and keep up the good work. We're really proud of you.
Thank you.
And then Analia, was she able to join on or is technology on her side?
For Analia, if you can hear me, go ahead and unmute yourself if you can. You should have the permission to talk in Zoom.
Well, that's okay. If she can join us, that'd be wonderful. If not, we do want to appreciate all of her hard work. And as we close this portion of tonight's ceremony, I really want to congratulate everyone who is there tonight, either online or in person. You know, it really takes the dedication of everyone to help an event like this to come together. So thank you for Ken and Jeff and Luis and everybody who's there tonight and online or even in spirit. You know, there's so many hardworking people. Sometimes it's hard to coordinate everyone's schedules. So big thank you. Your work connects directly to the future of aerospace, engineering, science, technology, and creative problem solving. Whether you're like the students who share their aircraft design or getting into the academics of fluid dynamics, solar activity, space debris, STEM innovation, or the future of space exploration, everyone's ideas matter. Really, to our students, my big message is to keep asking those bold questions, keep learning, keep creating, and most importantly, keep believing that your work can make a difference. Myself as a student, I remember staying up so late at night and all my friends would be asleep or partying or having fun in college. And there would always be that inner voice telling me, no, there's an idea in your mind, don't let it go. And that's what's really made a difference. And I feel everyone in this room has that same spirit of innovation. So to all the families, teachers, mentors, aerospace leaders, and AIAA members, thank you for supporting the next generation of innovators. And again, congratulations to all tonight's recipients. And thank you from the bottom of my heart for being part of this celebration. And now I'll pass it on to Luis. Thank you so much, everybody.
Thank you, Harvey. All right, so last but not least, just a quick recognition for an individual who makes the most awesome, cover art I've ever seen for a newsletter. If you look at one of the last pages in the program for the aerospace art newsletter cover design, Mr. James Vaughn. Vaughn. I know they're black and white, but if you don't receive our newsletters, these are just some of the examples that he uses. All freelance work is all his work, and it's very astounding. I look forward to receiving this in my inbox every month because some of the graphics are just phenomenal.
What's like a projected?
Yeah, and PDF here of some of the progress you've made over the past few years, months. It's always something new, it's always something fresh. So yeah, I just wanted to recognize that, is that really, that makes our newsletter, it's one of the best ones, I would say. So thank you, Mr. James, so on. With that recognition, that concludes our evening. Thank you so much all for coming tonight. I really appreciate it. I had a fun time. I hope you all did too. And I hope to see you all next year. Thank you.
And you know, we'd like a group picture of the folks in stage with Bill Ayler and Barbara and Jeff and everybody else with Jeff. If you could all come around there.